Hello all, welcome to the channel. Today we are solving question number 16 of next 2025 exam. So the question says a PN junction diode in a circuit is in reverse biased but not under breakdown condition as compared to the PN junction diode in forward bias. Okay, so it says we have a PN junction diode that is in reverse biased. That means the P part is connected to the negative terminal of the battery and the N part is connected to the positive terminal of the battery. Now P the P part of the P-N junction diode has majority of holes in it and minority are electrons. In the N part, majority are electrons and minority are holes. Now, the region between P and N, this is known as the depletion region. This region acts as a barrier to further movement of charges based on the connections forward or reverse bias. This region is known as depletion region. Now, in this region, a layer of protons and electrons are formed, electrons and holes to be precise. Let's say, yeah, let's say near the P part there is a layer of electrons and near the N part there is a layer of holes. Now when the circuit is turned on in the reverse biased, the negative from the negative terminal electron will be emitted. It will travel the circuit, reach the P type P part, occupy one of the hole. Let's say it occupies this hole. Now this hole there is an electron. To complete the circuit, there must be a release of electron. That means a electron has to vacate its place and a hole will be formed. Similarly, this circuit goes on. After some time, there will be more number of electrons here and there will be more number of holes in the inside. Therefore, it after some time there will be a point when there will be another layer of electrons formed. Therefore, it will act similarly as increasing the depletion layer width that says in the option A. The layer, the width of the depletion region will increase due to the further addition of this layer of electrons and this layer of holes. That's why in reversed bias the depletion region width increases while in forward bias opposite happens, and due to that the depletion region width decreases. In reverse biased its width increases and in forward biased the width of depletion region decreases. Now next thing it says what will happen to the barrier potential. What is barrier potential? Barrier potential is this. The depletion region means what is the barrier? It acts as a barrier to the flow of electrons from holes to the P, from P to N, and electrons from N to P. That means in a reversed bias the width of depletion region has increased, therefore the potential barrier has also increased. And in the forward biased, if width is decreasing then the potential barrier width is also decreasing. Therefore B is not the correct option, A is correct. Let's move to C. C says the current enhances significantly across the junction. In reverse biased, due to the increase of this width of depletion region, now the holes from P side have to travel a larger distance to move to N sides for conduction of current, because generally a PN junction diode operates in forward biased, not in reverse biased. Unlike it is only possible in Zener diode, that is a reverse biased. But apart from that, mostly all the PN junction diode they act in forward biased. So that's why current will decrease, not increase in reverse biased. Fourth option says the electric field across the junctions changes sign. Okay, so let us first visualize the electric field in the depletion region. I have the depletion region like this. There are layer of electrons and layer of holes. Okay. Now electric field, what is the direction of electric field? It moves from N to P. This is the direction of electric field, correct? Okay. Now it says electric field across the junction changes sign. That means if I move from forward bias to reverse bias, this electric field direction will reverse like this. Is that the case? Let us examine. The only thing that happen in positive bias to reverse bias, forward bias to reverse bias, is that initially in forward bias the width of depletion region is very small, and when I connect it into the reverse bias, this width keep on increasing due to addition layer of electrons and holes. That means the layer will increase, the density will increase, the thickness will increase, but the electric field will be in the same direction as original. Its direction will not change. That's why option D is also incorrect. So the correct answer for this question is option A. Hope you understand the solution. Thank you for watching.